Good day, grade 12 learners. Welcome to today's technical maths lesson. My name is Moses Maudu. This lesson is brought to you by Gauteng Department of Education in collaboration with the Sabono Discovery Center and broadcast by Pagama Research and Development. Please send us your messages on this WhatsApp number 079 578 2908. 079 578 2908. Please send your questions to that number or send your comments to that number. The number I'm going to repeat it again, 079 578 2908. Now, today's lesson will be on Euclidean geometry. Back again with the Euclidean geometry. But the part that we're going to do today, it is the proportionality. So that is part 3. Remember, we've done 2 parts in Euclidean geometry. So this is the third part. Proportionality is a theorem in grade 12 that we're going to be looking at. We're also going to look at midpoint theorem, because midpoint theorem we've done it in grade 10, but in grade 12, then we also use it because it works nicely with the proportionality. Now, the objectives of today's lesson will be, by the end of this lesson, we want you to be able to do the following. You must be able to apply the proportionality in triangles. Remember, here we're working in triangles. We can do proportionality in any other figures, but we are going to concentrate on the triangles. To apply the midpoint theorem, we must be able to apply the midpoint theorem so that then we know how to apply the midpoint theorem in order for us to understand what we're going to do in proportionality. Now, just to introduce you quickly to the ratios and proportionality. Now, if I have, what is a ratio, by the way? It is a comparison of the size of two quantities of the same unit. So, and what is proportion? So when talking about ratio and proportion, the proportion will be the mathematical concept which states the equality. Now remember, the equality of the two ratios. I can just quickly cite an example. If I've got 2 over 3 and the proportionality, then if I multiply that one by 2 and multiply the bottom by 2, so I get 4 over 6. So that is the equality of those two ratios. When two sets of numbers increase or decrease in the same ratio, you see what I've done there? I've multiplied that by 2, I've increased that with the same number there. So therefore, they're said to be directly proportional to each other. Okay, so in case of the ratio, if I've got 2 is to 3, and I'm given maybe, for instance, 20 centimeters, and I want to find out what will be the ratio to of that one. So I'm going to say 2 over 5. So I'm going to add the two numbers, then multiply by 20. So that will give me 8. So for this part here, I can write 8. And for the other part, I can use 3 over 5. I multiply that one by 20 again. I'm going to get a 12. So this and that are the same. But in its simplest form, it will be like that. So it will be 2 is to 3 for the 20. So if you look at these two numbers, if I add them, I'm going to get a 20. So that's how we use the ratio. Done this in grade 9. So I'm just reminding this you this. Now let's look also at the shapes. We're not talking about shapes. There we're talking about the numbers. Now let's talk about the shapes. When shapes are in proportion, their relative sizes are the same. So meaning that in the picture below there, so we've got 2 dogs there, love dogs. Below are the ratios of a head length. See, we're talking about the head length to the body length. So it is the ratio of the head length to the body length of the 2 dogs which are in the same, which are the same in both drawings. You see, those dogs are the same. Now, in this case, what are we looking for now? So we're talking about the proportion. The proportion of the head to the body is 10 over 20. In the other dog there, the proportion of the head to the body is 15 over 30. If I check this, 10 over 20 will give us 1 over 2. 15 over 30 will give us 1 over 2. So the two dogs, the head, the proportion of the head to the body length of one dog is the same as the proportion of the head to the body of the other dog. So they are in the same proportion. We are not saying that the length of the head and the length of the of dog A and the length of dog B are equal. No, we are saying they are proportionally equal. So they are proportional. So the head to the body of one dog, dog A, is proportional to the head length to the body length of the other dog. Now let's look at this next one here. If I knew the length of this of this one, what am I going to do? So I'm going to do the same way. I'm going to say the proportion, the ratio of the head to the body. So it is 10 over 20 of dog A, and this is dog B. So now I'm going to say it will be the same as the proportion to the head of the next one, which I don't know, over the body of the other one, which is 42. So how am I going to get the unknown? So I'm going to cross multiply. I'm going to say the unknown is equals to 10 multiplied by 42. Then I'm going to divide that one by 20. So then I'm going to get the unknown there, that is the length of the head length of the dog B will be 420 divided by 20 by 20. So the 0 and the 0 cancel out, and then from there we got 21. So in other words, the length of the head of this other dog is going to be 21 if it's measured in centimeters or so. Okay, and this is exactly what we're going to be doing in the questions that follow now. But before that, let's look at the midpoint theorem that was done in grade 10. So the midpoint theorem tells us that if I've got a triangle ABC, and I've got a line that connects the midpoints of two sides of the triangle. So in other words, if it connects the midpoints, it means that that line is equal to that. This line here is equal to that. It connects the midpoint of the. So the line segment of the triangle joining the midpoints of two sides of a triangle. So what does it do? What does that line do? It becomes parallel to the third side. Okay. And it is also half the third side, meaning that DF will be half of BC. Okay, so DF will be half of BC. So meaning that the line here is half of that. So that is the theorem that we're going to be working with. So if I'm given that line as 5, it means that that line will be 10. So it is half of it. So the line that is given there as 5 will be half of the line that is given there, which is BC, which is going to be 10. That is what the theorem says. So if I'm given that, I must be able to can work it out. Now let's look at this activity 1, which talks to the midpoint theorem. Now it says, I can now see that if this line is equals to that line, and that line here is equals to that line, AP equals to PB and AQ equals to QC. That for me tells me that this line is parallel to that, and PQ is going to be half of BC. So that is what it means. So the theorem states that PQ is equal to half of BC, and it's also parallel to BC. So PQ is given as 2x minus 4, but BC is given as 32. So I'm given that, so I'm requested to calculate, to determine the value of x. Now, let's see what we're going to do. So we're going to say 2x minus 4 equals to half of 32, which is going to be 16. Then we're going to transpose the 4. So we're going to have that as 20, and my x value there is going to be 10. So in other words, if I put x to be 10, then I'll have 2 times 10, which is going to be 20, and 20 minus 4, it's 16, and this value there is half of the BC. So we can see that that theorem is true by using our calculations. Now, the next activity, before we go to the next activity, let's look at the proportionality theorem. Now, the proportionality theorem states that, now this is very important, and please check this with your midpoint theorem. The midpoint theorem states that if the line divides the midpoints of two sides of a triangle, it's parallel to the third side and it's half the third side. Don't confuse the midpoint theorem with the proportionality theorem. Now, the proportionality theorem states that if I've got a line drawn parallel to one side, you see, I've got this line here drawn parallel to the other side, meaning that that line is parallel to that side. But can we then say it divides the other two sides, it divides the midpoints of the other line? No, it does not. It is not a midpoint to the other two lines. So what are we going to say? We say it cuts the other two sides so as to divide them in the same proportion. Now let's go back to this. The line parallel to one side of a triangle cuts the other two sides so as to divide them in the same proportion. What does this mean? It means if this line is parallel to this line, it means that the sides will be in the same proportion. So meaning that if I have AD over BD, on the other side I must have AE over EC. That is what it means. It means that it's divides the other two sides in the same proportion. So here is the first proportion that we are going to be working with. So we said AD over BD is the same as AE over EC. Okay, so if I take AD over AB, can you see what I've done now? I've said AD over the whole. So I'll then say AE over the whole. So the whole there for this one is going to be AC. So I can write that proportion in that form. Can you see how we can write this proportion? So we're able to get to have more proportions. You find that sometimes we're given the whole length and this part, and you need to do the other proportion. So take note of that. Now, if we look at this activity 2, it talks to that. Oh, nice. Can we then say this line is equal to that? No, it can't be. What is the reason? It is because it is not the midpoint theorem. It is the proportionality theorem. Can you see? Then in the proportionality theorem, what do we say? We then go back and say, okay, this line here, it's parallel to that. So what does it mean? It means that the two other sides are divided in the same proportion. Same proportion meaning that if I say this over that, I must say that one over that. Okay, so let's write that down quickly. Then I can say, if I say AE over EC, this must be the same as. I've started with AE, so I must start on the other side with AD. So it will be AD over BD. So that proportion over that is the same as this one over that. Can you see what I've done? I'm writing them in the same proportion. So I'm not saying AD over BD and this side I said CE over EA. That will be incorrect. So now let's substitute. We need the value of X. AE. What is AE? It's 5. What is EC? It's 3. What is our AD? Our AD is going to be X plus 3. What is our BD? It's going to be X minus 2. Then what do? We cross multiply. And when we have these ratios, we cross multiply to get to that. So I'm going to say 5 times X So it will be 5 times x, it's 5x. 5 times minus 2, it's negative 10, equals to 3 times x, it's 3x. 3 times 3, it's 9. Got a nice linear equation that I can work with. Nice. So now, say 3x, transpose it. 5 minus 3x will give us 2x. I transpose the 10 to the other side. I say 9 plus 10 will give us 19. And x will be equals to 9.5 or 9.5. I can write as 9.5. So I'll have those two as our answer. So one of that. So 9.5 or 9.5. You can write it in that form. So we know my x value is 9.5. My x value is 9.5. And then if I substitute my 9.5 on the value of x, I'll find that this proportion there will be correct. I want you to go and try it. Take these values, substitute them, and see if it gives you the same ratio. Remember, it must give you the same ratio. So it's either the ratio will have been increased or the ratio will have been decreased. Right. Now, let's look at another activity that deals with proportionality. Now we have a story. You see, in technical maths, you'll find that there are a lot of stories when they're doing this type of questions. So you'll have a story, and we have to relate what we have done in that story. Now they say, there's a wall that is 3 meters. So stands 1.5 meters from the building. So here is this wall that they're talking about, which is 3 meters. And that wall stands 1.5 meters from this building that we are having here. So we're having a building here. Right. One end of the straight pole rests against the building. One point of the pole, there's a straight pole there, rests against the building. And the other one touches the ground. So it touches the ground there. Right. 4 meters from the wall. So here's the wall, remember? Here's the building, here's the wall, here's the building. So now they say it's 4 meters to the wall. So that's 4 meters. So we have the 4 meters. A point on the pole touches the top of the wall, right? Now we need to determine the length of the pole. So we need to determine the whole length of that pole. Oh, I can see. And remember, this wall will always be perpendicular to the ground. So there's no way that that wall will be standing at a certain angle, but it will be always perpendicular to the ground if it has to stand like that. So there also, that wall also will be perpendicular to the ground. Okay. Now, what do I know? If this wall here is perpendicular to the ground and that wall is perpendicular to the ground, what do I know about these two? I can hear you saying, oh, okay, I can see 90 degrees there, I can see 90 degrees there. It means that those angles are corresponding angles, which are equal, meaning that that wall will be parallel to the building. So if they're parallel to the building, what can I then... I know my theorem will now work because I've got two lines that are parallel. Okay, a line drawn parallel to one side of a triangle. So that line is drawn parallel to one side of the triangle. Okay, divide the other two sides in the same proportion. But now I'm having a problem. If I use my proportion, then I'll have this side over that side equals to this side over that side. But I have a problem because I've got two unknowns there. What can I do? Okay, I think the best way to do it from now will be, oh, okay, I see this is a right angle triangle. Now I'm going to name this thing. Let me name it as A, as B. I can name that one as C. I have that top part here will be my E. I can have that part here as my D. So I've named it so that I can work out my values. First, I can work out that part because I can work in triangle ABC, which is a right angle triangle. And what do you need for a right angle triangle? Oh, two sides to get the other sides. Which theorem do I use? Pythagoras. Okay, I've got a 3 and a 4. Oh, I love 3 and a 4 because that's a simple one. How do I then get my AC in this case? So I'm going to say AC squared equals to 4 squared, 4 meters squared plus 3 meters squared. Because I've got those two sides, I need the hypotenuse. Oh, no, that's 25. My AC squared is 25. So meaning that my AC will be equals to 5 meters. So now I've got the length of this one is AC, which is going to be 5 meters. But I need this part CE here. I'm going to get CE. Oh, now I see. Okay, I can use my, what do we call this? My proportionality theorem. So how am I going to use my proportionality theorem? Remember, I must also write the reason. So the reason for this, remember, it is the proportionality theorem. And then I must write down the two sides that are parallel. I'm going to write it now. So how am I going to do it? I'm going to say AB over, so remember I'm starting with AB over BD. So over BD, it's equals to. So now I'm going to go to AC. Remember I started with AB. So I'm going to say AC all over CE. Okay. So now the reason will be proportionality theorem. Then I can write down my sides that are parallel, which is going to be BC. In this case, is parallel to DE. Okay. So now I can now substitute. AB, it's 4. The BD, it's 1.5. AC, I have it's 5. And CE, I don't know. So I'm looking for CE. Why am I looking for CE? Because I need the whole length, but I've got part of it. So now I'm going to say CE, it's equals to 5 cross multiply, 5 times 1 comma 5, and then divide that by 4. If you're using a calculator, please, let's check if my answer is going to be correct. I think my answer there is going to be 1,875. Okay, therefore, to get my AE, which is the length of the pole, then I need to add the 5 plus 1,875. And the AE will now be equals to 6,875. To the nearest, that will be 6.9 meters. Okay, depending on what the question wants. So now I've got the length of the pole. Remember here I must write length of the pole. So I must write down the length of the pole AE according to what I've done on my diagram. Remember when you're writing paper 2, your paper 2 will have that sketch will be on your paper, and you can then name them so that when we mark, then we are able to see when you're talking about AE, we know what you're talking about. AC, we know what you're talking about. Okay, nice question here. Right. The next activity, it's straightforward and simple. Next activity talks about a triangle being given. All the sides, what do I know about this? How do I know its proportionality theorem? Once I see lines that are parallel, this line is parallel to that, then I immediately know, oh, this is a proportionality theorem. So for this one, I'm going to give you 2 minutes to look at this question. 3 minutes, let me give you 3 minutes to look at this question and quickly do it. And the marks on this question, it's going to be 4. Let's see if we can get the 4 marks on this question. 2 minutes or 3 minutes is going to start. All right, welcome back. Let's see how many of you got it right. Hopefully, I think I gave you the hint there. I think the answer is 4. Let's see if you were able to get a 4. But this one, I'm going to do it differently. Let's check this. Now I'm going to say PM over PQ. I know you have said PM over MQ. So I want to do it with PM over PQ and see if we're going to get the same answer. So now on the other side is going to be, is going to be PS over PR. Now let's check. Now remember, you must write down the reason. The reason will be proportionality theorem, and then you write down the sides that are parallel. Now PM for me is going to be X. PQ for me is going to be X plus 2. Right. Now, PS is going to be X plus 2 over my PR, the whole of PR, is going to be X plus 2 plus 3. So which is going to give me X plus 5. Okay, because it's going to be X plus 2, then plus this 3, so it's going to give me X plus 5. So that is the whole of PR. Okay, now I'm going to cross multiply. So I'm going to get X squared plus 4X plus 4. When I multiply the other one, then I'm going to get X squared plus 5X. So now the X squared and the X squared will fall out. So I'm now going to get 4X minus 5X, and I take my 4 that side, I'll get a negative 4. I'm going to get negative X equals to negative 4. Then the X value is going to be 4. So I've done it that way. So you see, you can do it, either I can do it that way, or I can go PM over MQ, it's equals to PS over SR. And in this case, you're still going to get the same answer that we got there. So please practice both. But with this one, it was easy for you to do it with PM over MQ equals to PS over SR. Please. Okay. Right. Now, let's look at the next activity here. Then we have too many parallel lines. You see, we're doing it with one parallel line. It was nice and easy. Now, let's look at when we have too many parallel lines here, but it's not a transparent. You just look at the triangle that you're going to be working with. So if I've got this triangle, I just look at the triangle. I see PQ and BC will work in triangle KQP. Can you see? There we have the triangle. Okay, so we have those two lines that are parallel. Then I can use my theorem. Now with this line parallel to that, I also have that line parallel to that, so I can use the bigger triangle. I've got this line here, PM parallel to BQ. I can use the triangle PMK. So I can use that. Now let's go to the given. It's very important for you to read the given information. It says BC parallel to PQ. We've checked that. And it's also parallel to LM. We have checked that. I've got a 90 degrees. Right? Fine with that. Obviously, if this line is parallel to that, those angles there will also be 90 degrees. Okay, they are corresponding angles. Now I've got BQ parallel to PM. We have checked that. KM is 15 units. It's there on the sketch. Check if every information that is given is on the sketch. PL is 4. It's there on the sketch. KQ, the ratio of KQ and QM is 3:2. So I must go to my sketch and put that in. So it says KQ. So KQ will be that whole line up to here. So that whole line there, I'm going to write 3. I'm going to write 3K because it is not the length. Okay, it's the ratio. So it's 3K. So for the other one, QM is this one here. So I'm going to write 2K because it is not the length. Because remember the length of that whole line is 15. So, but that the part KQ it's 3K and the part QM is 2K. Right. Now everything is on my sketch. I can now go to the questions because I've realized that there's no information missing. I'm fine with that. Determine stating the reasons, the length of QM. Now, you see now I need the length of QM. I cannot say the length of QM is 2K or it's 2 because it is not the length. If it's 2 and this one is 3, it gives us 5 and that length they say it's 15. Can you see? That's where we go back to our grade 9 work and work out the length of QM. So it is returning the length 3, in the ratio 3:2. So my QM is going to be 2. Remember QM there, it's 2K. So I'm going to write 2K over. Remember, I must add the 2, which is going to give me 5K, and that is multiplied by. Remember, I need the length of QM. I need the length. I don't need the ratio. I need the length of QM. So multiply by the 15. Remember, the K and the K cancels out. My answer becomes 2 over 5 multiplied by 15. Then I can then write down the length. 5 into 15 goes 3 times. 3 times 2 is 6. So my length there is going to be 6 units. So I now know that this one there is going to be 6 units. Right, I'm going to write it there. So obviously for me to get KQ, the whole length of KQ will not be, it will be 3 over 5 times 15, which will give me 9. So that whole length there will be 9. So 9 plus 16 now gives us 15. 9 plus 6 gives us 15. So I've got 9 and 6, and that gives us 15. Right. Now, the next one says, still the same data. So I'll have 9. I'm just putting the 9 and the 6. So then I know when I'm working out this, and I've got a 4, I've got a 15, so I'm covered there. Now I need KP. How am I going to get the length of KP? Remember, we're stating the reasons. For that other one, remember the reasons for that, for KP now will be, we are going to use the proportionality theorem. So KP, where's KP? I can see there's KP. KP is that line here. So now I need to find out what will be the length of KP. So the length of KP cannot be the same as the length of KQ. So I need to write the proportion. How am I going to write my proportion? I'm going to say KP over PL. I'm going to show you that now on the sketch. It's equals to KQ all over QM. So let's check that. So we said the whole of KP all over PL. Remember, I don't have KP, but PL I have. So I have a 4, so I'm covered with it. Now let's go to the other proportion. Remember, I'm working in triangle KML. So let's go to another proportion. So the other proportion will be the whole of KQ over QM. Now I know I have all those values. So the only value that I don't have it's KP. So how am I going to get KP? So I'm going to write down now KP over, what is my PL? 4. What is KQ? It's 9. What is my QM? It's 6. So KP, if I cross multiply all this, 4 times 9 is 36. 36 divided by 6 is 6, so I'll have 6 units. So you see I'm working. Why am I working in the bigger triangle? What do I see there? What will be my reason there? Remember, it's proportionality theorem. And then which lines are they parallel? I'm working on this PQ and LM. So it's PQ, it's parallel to LM. So you must write down, always write down the lines that are parallel in which you're working, in the triangles that we are working with. When you're practicing, please write down the triangle that you're working with, and then that will be much easier because then you are able to figure out which lines are going to be parallel. Now let's check KB. Already we have KP, so which ratio am I going to use? Now I'm working in triangle KPM now. I want to work in triangle KPM. See, that triangle that I'm going to work with. Why? I have two parallel lines, PM and BQ. I can work in those triangles. Because I can see that triangle I've got KB. Right. So let's write down the proportion. The proportion to that will be KB over KP. Let's check this. KB over KP. Can you see? And already KP I have. Oh, nice. So now the other proportion will be KQ over KM. Let's see. Do I have KQ? Yes. Do I have KM? Yes, I have the 15. I haven't used it. Let me use it. Nice. Now I'm going to have, what is KB? That's what I want. What is KP? I got it as 6. What is KQ? I have KQ as 9. What is my KM? I have it as 15. Now I'm now going to say, how am I going to now get the value of KB? So KB will be equals to 9 times 6, which is 54, and 54 divided by 15, that gives me 3.6 units. Now it will make sense for me that if KP is 6 units, that can be 3.6, and that should be 2.4. You see, so when you're working on that sketch, you must also see if your answers that you're getting are making sense. If this is 9, it looks bigger than that side. So please, we know that some of the sketches are not drawn up to scale, but it must make a bit of sense with your sketch. Okay, I know we try to make that to be to make sense, the sketch to make sense, because I cannot say that other length is 6 and the other one is 9, and we've got the 6 as a shorter, as a longer line than the 9. Okay, right. Now, here, so we're working with some of the triangles with a lot of parallel lines and a lot of lines, and I want you to see what we are up to here. In the diagram here, ABC is a triangle. Wow, we see a triangle ABC. Great. Read the given information. Even if you have to read it 3 times, please do so. D is the midpoint. Immediately, I go to my sketch and said, okay, D is the midpoint. What does it mean? It means that this whole line BD is the same as this whole line DC, because it's the midpoint. So if I know the length of DC, I didn't know the length of BD. If the length is 5, BD is 5, then it means that the length of CD will also be 5. So you see, I'm putting the information on the sketch so that then I. Now AB, the whole of AB is parallel to FG. It's indicated with F on BC. That's indicated also. AG, so I have AG, so it's 1, AG and to AD, it's 1:3. So I'm going to say this will be K, and the whole of AG, the whole of AD will be 3K, you see. So remember, it's a ratio, it is not the length of the line, it's a ratio. So you can write P or whatever letter you want to write there. So I prefer the K there, so the K and the K there. So I've got 1K there, and we've got 3K there. So it's 1:3. So if you look at that whole length there, so that whole line there, it's 3K. And this AG, it's 1K. So I can immediately put 2K on this GD, you see, so that then I know it's the whole length the whole line is 3K, and the AG is K. The rest of the line is going to be 3K. So I've put everything on the sketch. Nice. The first question says, determine with reason the numerical value of BF over FD. So I go to my sketch and said, okay, I need BF over FD. But I see I've got parallel lines here. So I can use my parallel lines. In which triangle? ABD. So my triangle ABD can work out here. So I'm going to say BF, see I'm starting that side. It's equals to AG over. So I'm saying BF, AG, FD, GD. So it's equals to over GD. Okay. So now already I've written AG, I know it's 1K, so I'm going to write 1K. GD, I already have it now because I said that line will be 2K. So I'm going to say that's 2K. The K and the K cancels out. Don't forget to do that. And the answer will be 1 over 2. Okay. So now we've got 1 over 2. BF is 1 over 2. So I now need to find the other length. Now the other length, the other ratios. Remember we're talking the ratios. They say you find the numerical value there, so which is going to be the ratio of that. Now, let's look at this one. Now, we need here to find the numerical value of CG. 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 So that line here. And CH. And CH. So it's the whole length. So CG and CH. Okay. Now, what do I know about CG first? So if I look at this whole triangle, the triangle CHB, that whole triangle, CHB, and I use the same ratio that I've done. CG, it will take CF. CH, it will take BC, the whole of BC. Okay, so now I'll have that ratio. So meaning that I'm going to have CG, it's CF, over CG. Remember here I've got, for AG, I've got 1K. Here I've got 2K. I'm going to write them like that. Okay. Then I already have this one as 1K and this one as 2K from the previous question. So it's CF over BC. But what do I know about the CF? So my CF is going to be my CD, right? So remember, I need CD. For me to have that, I need my CD. So I'm going to have CD plus FD will give me that whole length. So I'm going to say CD, this line, plus FD will give me the whole length of CG, of CF. Now, BC, how am I going to do my BC? The whole of BC. So, but the whole of BC will still be CD, but it must be added to BD. Okay, so the whole of BC, can you see BC there is going to be CD, the whole of CD, added to BC. Okay, now the length of CD, remember in the previous one, we got the length of BF over that. So now if I check the length of CD, what will be the length of CD? The whole of CD will be equals to 3K also. So my CD will be 3. If I check what my FD will be 2 divided by. My CD it's 3. But what is BD? The whole of BD there, it's 1K plus 2K, which is going to be 3. Then I can then quickly write down what is my value there. It's 5 over 6, meaning that CG over CH will be 5 over 6. If I use my other diagram, if I use that whole diagram there, because this line is parallel to there, I'll get those two answers. The 5 over 6. So my whole value there, the whole line there will be 5, and the smaller line there will be, so the whole line of CG will be 5, the whole line of CH will be 6. So you can see this is a smaller line than that. So it means that these ratios will be correct. Okay. Now, for the next one, I'm going to give you 3 minutes to do, let's say 4 minutes to do question activity number 7. 4 minutes to do activity number 7. For A, you'll have 2 minutes, and for B, you'll have 2 minutes, just to give us the reasons there, and also giving us the reason why the length of AE, what is the length of AE with the reason. Okay, so your 4 minutes will start. Right, welcome back. Now, in this activity 7, let's see if you got the two answers correctly. First, read the statement that is given. It's very, very important. Because sometimes when we go to the sketch and try to answer the questions without reading what is given, then we'll have challenges. Now, in the diagram, points A, B, and C are on the circle. So those 3 points are on the circle. It's fine. ABC is an isosceles triangle. Means that your terminology in geometry must be, Euclidean geometry must be sharp. Now, what does the word isosceles tells us? Isosceles triangle, it means that there are two sides that are equal. So meaning that in this case, they've given you the sides that are equal. They said the length of AB is equal. So immediately go to your sketch and indicate that the length of AB is equal to the length of AC. And indicated that DE is parallel to that. So what do I know? They will be in the same proportion. See, they will be in the same proportion. Now they say AD it's 3 units, BD it's 2 units, so they want the length of AE with a reason. Now, obviously, if this is an isosceles triangle, and we have this line parallel to that, and they are in the same proportion. So here it will be the same proportion. So meaning that that will be 3 and that will be 2. So they always be in the same proportion. Okay. So now, the reason for that, either you can say the isosceles triangle, that is also acceptable, or another reason will be the proportionality theorem, whereby this line D is parallel to BC. Okay, so AE, we know AE is going to be equals to 3 units. Okay, if they ask me about AC, it will be 5 units because those lines are equal as given. Now, B states that determine DE over BC and give reasons for your statements. Very important question. We have not done anything on DE on the lines that are parallel. And please, we cannot say DE is half of BC. Reason B, this is not a midpoint theorem. This line is not equal to that line. So this line that is not cutting the midpoints of the two lines. Right, it's not going through the midpoints of those two lines. So now the AE is 3 units as you know. DE, we don't know what is DE. BC, we don't know what is BC, so we don't have that. Now, next time in the next lessons, you're going to be doing similarity of two triangles, of which we have done some of these things in grade 9. Now, if this line is parallel to that, that will mean that this triangle and that angle will be equal because they are corresponding angles. This angle here and that angle will be equal because they are also corresponding angles. And this angle there will be a common angle to the two triangles. I'm talking triangle ADE and triangle ABC. So they're similar triangles. See, the similar triangles, then this is the ratio that we're going to be looking at. So the ratio that we're going to be looking at is, please pay attention, AD over AB. So I'm going to say AD over AB. So I'm taking this small line there over the length of the other line, the bigger line. So this thing here will be the same as DE over BC. And you'll understand this much better when you're doing your similarity. So, meaning that it's what I need here. So in this case, what is my AD in this case? My AD is going to be 3. And my AB is 3 plus 2, which is going to be 5. So the answer to this will be 3 over 5. So please make note of that when I need these two lines, I then take AD over the whole of AB, and then I then take DE over BC. See, that's what we're going to do. Okay. All right. Now, the next one that we need to do is activity number 8. Again, there's this story that we need to read. I know tech math learners are so lazy to read, but sometimes the answer is hidden in that paragraph. And you go to the sketch, you try everything, then after some time, then you go back to the sketch and you want to check the sketch, and voila, the answer is there. Okay. Now, for this one, as we do again, for A, I want you to also practice this one because there's something that I want you to check with the length of AB, and again with the length of AD. I want to check. Oh, sorry, the value that you get for AB and the value that you get for AD. I want to check there. So with this, I want also to give you this one so that you do question 2, but for question A, I'm going to do it with you. So let's first look at the sketch and read what is happening in the sketch before we give you the next one to do. Now, the diagram shows a side view of a shed CEDB. So let's check CEDB. So, and a ladder FA leaning against the diagram. So now, against the building. The building is AC. There's the building. The rectangular shed CEB. Now we're told this thing CEBD is a rectangle, meaning that if this side is 2, that side will be 2. If this side is 3, this side will be 3. Okay. The shed stands against the perpendicular building. Perpendicular building meaning that there's a 90 degrees. Nice, it's there. Now it stands 5.5 meters. The height is 5.5 meters. The ladder FA, so we have got a ladder. Here's the ladder FA here. Is used to gain access to the roof of the building. AF is the minimum length of the ladder. So this AF here is the minimum length of the ladder. EF is the minimum distance. So EF is the minimum distance from the foot of the ladder to the shed. So EF is that one. Now, the first question says easy questions. So I've got everything on my sketch. Easy questions. Why is DB, this line here, why is this line here parallel to this line here? Oh, now we know, we're told that it's a rectangle. In a rectangle, opposite sides are equal and parallel. Or what is the other reason here? This side here being parallel to that side. The other reason might be that I have a 90 degree there, I have a 90 degree there, so I can then say, in this case, angle ABD, it's equals to angle ACE, and they're both equals to 90 degrees. So which makes them corresponding angles. Remember, corresponding angles are equal if the lines are parallel. So we can have corresponding angles why the lines are not parallel. So it is very important that you write down corresponding angles equal, because if they're equal, therefore the lines are parallel. So the reason there will be ABD, angle ABD, angle equals to angle ACE, which are both 90 degrees, and those angles are equal. Why? And then they are going to be corresponding. Why they are corresponding? It is because they are equal and the two lines are going to be parallel. So that is the reason. I've said so much on this reason, but the simple explanation will just be the two angles are equal and their corresponding angles are equal also. Okay, right. So the one that I want you to look at and do is B and C. So for B, and let's B, it's an easy one. I'm going to give you 1 mark for this one. It's very easy. And then the next one there, I'm going to give you 3 marks. Okay. So 2 marks, 2 marks. And therefore, this question will be 3 minutes, starting now. Okay, welcome back. Now, the question that I wanted you to do, it's B and C for 3 marks. Now, let's check this. Determine the length of AB. So we're still in the same sketch. So now we need to find the length of AB. This length there, we said it's 1 mark. So we don't need to waste time there on this one. We know that the whole length of that building, it's 5, 5. So I know I've got 5, 5. But I'm told that C, E, B, D, B is a rectangle. So if it's a rectangle, we said the opposite sides of a rectangle are equal. So meaning that that side will be 2, that other side will be 3. So if my CB from C to B it's 3, and from that part to this part it's 5.5, then I need to find what that part is. Okay, so now what do? I'll say the length of the building, which is 5.5, subtract. So I need to find the length of AB. So what should I subtract? I must subtract the length of BC, which is going to be 3. So the length of AB is going to be 2,5. So if I add 2,5 to 3, then I'll get 5,5. So that one wasn't quite an easy question. So now there I'm going to put 2,5. So I know that that side is going to be 2,5. What do I know about these lines? They are parallel. So if they are parallel, then I know in triangle FAC, see FAC, that whole triangle, I have this line being parallel to that line. Now you're asking, why is that whole line parallel? Because that is a straight line. So if it's a straight line, if EC is parallel to DB, it means that that whole line there is going to be parallel to BC. So if they are parallel, I know what this side is. I know what this side is. Then I can get the ratio. So I can get the ratio of AD is to DF. Remember, it is the proportion. It is not the length of the line. So let's check. AD over DF, it's equals to AB all over BC. So I'm saying AD over DF is the same as AB over BC. And that is not the length. So let's check what is our AB over, what is our AB? So our AB is 2,5, we got it there. BC is going to be 3. So meaning that my AD over DF, it's equals to 2,5 over 3. So that's 2,5 and that is 3. But if I look at this side and that side looks to be the same length. But those are not length, as I say, those are our proportional, our ratios. These are ratios. We say the ratio of this over that is the same as the ratio of this over that. Because that side cannot be 2,5 and that 2,5 because that makes that an isosceles triangle, and we cannot have an isosceles triangle in this manner where that angle is 90. Okay, so remember then it must be this side and that side, that must be equal to make it an isosceles triangle. So for me, this is a good question that tells you about proportionality, that those two are not in the same proportion. I mean, those two are not equal sides, but are in the same proportion. So that is why most of the time we find that we write a K there and we write a K there to show that it is the same proportion. So it can be increased. So we can say 2.5 multiplied by 3 and 3 multiplied by 3, and that will be in the same proportion again. So remember, those are not lengths. In this case, they are in the same proportion. Okay, right. Now the next activity, very nice activity. I love it when we have, a combination of those parallel lines and in one triangle, and let's see how we're going to do that. Now it says in the diagram, because this is exactly what I want you to do also. I want you to do this activity again. I'm just going to explain first the activity and then I'll do the last one also. In the diagram, AB See this AB, this line, is parallel to CF. See that line there, those two lines are parallel, meaning that I'm working in triangle A, B, D. See, the whole triangle. Then the next one says BF, it's parallel to CE. Again, in which triangle am I working with? I'm working in triangle BFD. So it is very important that you identify the triangles that you're working with in those parallel lines. So we can see in the triangle BFD, we have these two parallel lines. And in triangle BABD, we are working with triangle FC and parallel line FC and AB, those two lines that are parallel. Now, determine the following. You're also given that DE over FE, you see, it's 5 over 4. It's a ratio. So meaning that DE, let me check DE. Where's DE? DE is this line here. They said the ratio to this is 5 over FE, which is going to be 4. So I'm going to write this one as 5K and 4K, because those are the ratio. So immediately on your sketch, you can be able to see, okay, if I can work in triangle BFD, I can be able to work with the ratio FE over FD and CD over BC. But in the whole triangle here, I still miss my AF there. Okay, but we'll see when we're doing this, then you'll be able to see what we are going to get when we do the ratio of the bigger triangle. Now, in the next 3 minutes, I want you to do A and B, and then from there I'll do the C after we've done A and B in the next 3 minutes. I think 3 minutes will do, please. 5 seconds. Okay, welcome back. Now, in the diagram, as I say, AB parallel to CF, we have done that. Now, if I'm looking at this triangle here, BFD, this triangle BFD, I can have E over ED, it's equals to. So FE over DE, it's equals to BC over CD. Or I can write it as ED over FE, it's equals to CD over BC or CB. So, what is ED over FE? ED is 5K over FE, which is 4K. It's equals to CD over BC. So the K and the K will cancel out. Then I can have CD over BC is equals to 5 over 4. Now remember, I can write this one as a ratio. So I can say DC is to BC. So you see, it's DC is to BC. So what will be my answer there? It will be 5 is to 4. Okay, so I can either write it like this, or I can leave it like that. So it will be the same. Remember, if I've got 2 is to 4, I write it as 2 over 4. Okay, right. Now, the next question is about the area. We've not done anything on the area, but now I know in grade 8 and grade 9, you've done the area of a triangle. We're working with the area of the triangle. Here, I'm just going to put that the ones that we had at BC. We said BC, it's 4K. So the CD, it's 5. Okay. So the whole length will be 9. Now, here I'm now going to talk about the area. Now, the area of triangles. What is the area of the triangle? We have got 2 ways of doing the area of the triangle. It's either we can use the height, the area formula with the height, or we can use the area formula with the 2 sides and an angle, which is the area rule that we have done in trigonometry. So in this case here, let's check what is going to be suitable for us. Now, if I take the area rule, for instance, so it means I must have a triangle. I must have this side and that side, and the angle must be included. So in other words, I must have 2 sides and an included angle. So in this case, I don't have any angle that has been given, but maybe I can use any other angle so that they cancel out. Remember, we need the numerical value of the area of this over the area of that. Area of triangle FBC over the area of triangle FCD. So remember, we need the ratio to that. But if I check my triangles, I'm going to shape my triangles and see if they are separate. If they are separate, it means that I must do something with the height there. I'm going to check this triangle FBC. So triangle FBC is this triangle. Oh, now I've got only one side in this triangle. Only one side, which is going to be 4K. That I know. Again, I've got triangle FCD. So I'm just going to quickly shape this triangle FCD. I have triangle FCD. Right. And those 2 triangles are separate. You see, if this triangle, the other triangle was inside the other triangle, then it was going to be easy because I'll use one angle. Okay, so but in this case, they're separate. With this one, it's nice because I've got 5K. I also have this side here, which is 9K. So I've got that whole side, which is 9. I've got this side, which is 5. I can use the sine rule here. I can use the sine rule because I've got an angle here. But I don't have the size of the angle. That is my problem. So with the area, you must be very careful. Now, here is a very important statement. If I use the area with the height, this means I'll have area of a triangle FBC. If I use FBC, the height of this triangle, and make BC my base, that will be my height of the triangle. Nice. So I'm going to call this one my height. But I have another triangle here, which is FCD, of which the height of this triangle will still be the same. Remember, if I've got a triangle like this, the perpendicular height will be there. But why are the heights going to be the same? It is because they are between the two parallel lines. So triangles that are in one big triangle with two parallel lines, the height of those triangles will be the same. So I've got the height of this triangle. I can see that is the triangle, my height. You see the base there is going to be CD. The base there is going to be, we've got the same base. So the same base, their heights are going to be equal, right? So the height of this triangle FCD is that one. The height of this triangle FBC is this one, meaning that they've got the same height. So what am I going to write now? I'm going to say half of, in triangle FBC, the base is going to be BC. So it's multiplied by BC. Multiplied by the perpendicular height, which is this height that I was talking about, divided by. But what is the base of this triangle FCD? The base of triangle FCD is going to be half of. The area of that will be half of. What is the base? It is CD. Multiplied by the perpendicular height. Nice. So what am I going to have here? I'm going to have a half and half will cancel out. Perpendicular height is going to cancel out. What is left here? It's BC over CD. Can you see why this question was asked in in A? It was asked because we wanted to find out how are you going to get the area, the ratio of the two areas of those triangles. So BC is going to be 4, but CD is going to be 5. So that is the numerical value of that. So remember, stating with the reason of that, it will have, those two triangles will be having the same height. So if the two triangles are having the same height, this means that we then have the heights cancelling out, the half and the half cancelling out. What is left? We are left with BC over CD. So remember, if the two triangles have got the same base, so same base, then obviously their heights are also going to be the same in this case. So same base, they will have the same height, okay? If they're drawn between two parallel lines also, if I had a triangle inside here, that triangle drawn here, and I've got another triangle drawn somewhere there, because they are the same, they're in between the same parallel lines, then they'll have the same height also. Okay, so the proportion there will be their basis. So the proportion for that will be their basis, and we will have BC over CD. And this is the typical examination question you must understand. Sometimes you'll be given two triangles that are one triangle that's inside the other triangle where they share an angle, If they share an angle, then use the sine rule. So the area rule that we have done in trigonometry. So if they are separate, but they've got the same basis, use the formula that you know, which involves the height of that triangle. All right. The last question on activity 9, it's AF. Get the AF over FD. And remember, AF is the same as the BC. So if I use that, so my AF will be the same as BC. If I use this line and that line as my reference, parallel lines. So therefore, this we know it's already forking, so that is going to be forking. But we need that over FD, you see. So our FD will be the same as that, so it's also going to be 5K. So therefore, that is going to be 5K. So our AF over FD will still be 4 over 5. Okay, so because of those two parallel lines that we're going to use the ratios of this one and that one of those two parallel lines in triangle ABD. So that is an easy question that we needed to do. But if I've got AF over AD, therefore it will be AF over AD. That was going to be 4 over 9, because then we have to add the 2. All right. Maths practice, please. Conclusion, practice, practice, practice. And then from there, you need to ask questions where you don't understand, so that you get good marks in your technical maths papers. Thank you so much. And next week it will be similarity. Thank you.